All right, everybody. In today's video, we are going to be learning about switches. More specifically, we're going to be looking at the push button and a double pull, double throw switch. These two are the exact same. This is the style I'm going to be using in most of my videos, but it's a little small, so this is just easier to show you guys what I'm talking about, but they both have this and 6 pins. So put this on the side. We have different types of switches. They're not all the same. First, we are going to start with this guy. Start with the push button. This is the symbol for one. I like to picture this as these are the circuit, the circles, and then this is like a wire. As you can see, they're not making contact, so it's like an open circuit. Say this is going to like that's our voltage source and to ground. So right here, our circuit is incomplete. Because of this open. Now, if you were to push this little piece right here down, which is the button, push button, then what happens is this bar, this wire, gets pushed down and kind of it like connects these two, which completes the circuit. So why, let me ask you this, why do we have this line but we have 4 legs? What's up with that? Well, this is how I like to view it. This is like a top-down view. Exactly like that. I like to picture it like this is all one wire. It's all complete. So this leg here is connected to this leg. Always. There's a wire. It's always connected. Likewise, this line right here, you can imagine it like a wire. It's always connected. So these two always connected, and these two always connected. Where we're not connected is right here. But I kind of drew that here like triangles, like they're like almost connected, but not quite. And if you were to push this down, imagine it like pushing down the top of this triangle, and that's going to spread these out, and it's going to connect now this to this and this to this. If you're a video gamer, say PlayStation or any console, this is like your right hand right here. This is your X, circle, triangle, Y, B button. That's what these are. They're push buttons. So I have a little setup here, so I can demonstrate to you guys. So what we have here is a push button, and this break right here, there's no continuity between these holes and these holes. But I mean, like I said, it's pretend like there's a wire in here, and it's connecting this one to this one, and this one to this one. I've hooked up, or I've connected these wires in line with the legs so that we can test for continuity or ohms, so I can further explain to you how they are connected. So for those of you that don't know, you can go to your ohms or continuity test. So right now this is open between the circuit. Right now, if I touch these two, that's a short. I'm measuring near 0 ohms, right? Open, short, circuit, open, circuit, connected. But there's nothing in between. So that's how that works. The beeping, that just means that there's a short. So these bottom ones, like I said, are always connected. And these top ones are always connected. Okay? Now look at this. If I go to check these two, nothing. Nothing. Okay? That's expected, and that means the button is doing what it's designed to do. Now, let's go ahead and hook these up. Okay. Right now, it's open circuit. They're not connected, right? So now when I push the button, they're connected. That's what a button does. That's how we expect it to work. So if I have a question for you. If these two are always connected, and when I push it down, these two connect, then what about this one? So would this one ever connect to this one? When I push this down, would I be expected to see these two touch? Think about it. Yes. Yes, we should. Why is that? Well, if you think about it, when I push that button down, it's connecting these two, right? But this one and this one are always connected. So when I push this down, really all of them are connected. Just wanted to show you a visual example. That is a push button. I kind of drew one. Alright, you're gonna have to get out of here. I kind of just put one right here in the circuit so you can kind of see what it would look like. This is like a little buzzer. So right now, it cannot get electricity because it is open. So this buzzer will not make noise. As soon as I push this down though, then this will go down, connecting them, and the buzzer will make noise because the circuit will then be complete. Next, we are going to talk about this kind of switch. This is capable of being a double pull, double throw switch. Has 6 pins. What is a pull? What is a throw? Two very good questions, and I would expect you guys to ask that. A pull is how many separate circuits a switch can control. So I'm going to show you here. We have this very similar circuit to the push button one up here. Very similar one right here. This is a single pull, single throw setup. And that's how it would look. Single pull, single throw. So a pull is how many separate circuits a switch can control. Well, this is all one circuit, right? This switch controls one circuit. So it is one, singular. So it's a single pull. Throw. What is a throw? How many positions each pole can be connected to? Well, this circuit is either complete or incomplete. So it can only connect right here to one terminal, one output. So this is called a single pole, single throw. If you don't grasp the concept yet, I have a couple other circuits to show you and everything will click. So this is a single pole, single throw switch. Basically on or off. When the switch is off, we're not going to be getting noise because look at here, this is open. But when we turn on the switch, flip it up, then this will go down, making the circuit complete, and we should expect to see a noise from our buzzer. Okay, moving on. This is our next circuit. Notice very similar. Very similar. We got a buzzer. Okay. We got a switch. This is a LED, a light. What would you guess this kind of is? So again, poll. How many separate circuits a switch can control? Well, this is still one circuit. This right here will either connect this terminal to this terminal or this terminal to this terminal. Either way, this is a circuit right here, or this is a circuit right here. So it's only one circuit. So again, this is a single pole. However, how many positions each pole can be connected to? Look, it has two positions now, unlike this. This could only be to one connection. So now this will be a single pole, they call it double throw. Single pole, two throw, I kind of want to say two throw, but it's a double pole. Or double throw, sorry. Double throw. Hopefully that makes sense. If not, we're going to do one more. What do we got here? This is really two of these. So we got 4 LEDs here. Let's just say whatever. This is a red. This is a green light. This is a blue light. This is a yellow light. RGBY. Okay, so going back to our definitions, pole. How many separate circuits a switch can control? Well, this can control 2 separate circuits. We have this circuit, 3 volts, and 4.5 volts. So this is it's controlling two separate circuits. So this would be called a double pull and throw. How many positions each pole can be connected to? So we have two poles, but each pole can be connected to two, just like this right here. And this is a double throw. So this is a double pull, double throw configuration. Now let's look at the physical component and see if we can make sense of this. How do these work? I briefly went over it in my first video where we set up our power switch. As you can see here, we have 6 pins. There's really 4, where are my tweezers? There's really 4 connections. So when we have the switch in, let's call that off, the down. When it's in this position, it's connecting these 2 terminals right here together and these 2 terminals over here together. When I flip it up, it is now connecting these 2 terminals together to, you guessed it, these 2 terminals together. If you want, we could even test it. So look at this. Again, I'm in ohming mode, so shorting. Alright, I'm gonna try to, let's see, connect. So right now we're in the up position. So I should expect to see the middle pin. And when I touch this top pin, there's a connection. Now if I were to turn it off, I can touch those 2 again and nothing's gonna happen. But now there's a connection between here. Cool. So this can control, yeah, this is a double pull, double throw. So we can have it look just like this. In this instance, you would have the poles be the middle connections, the middle pins, and then it would switch up. So think of it as like this would be the bottom pin, and this one would be the top pin, and this, your source, would be the middle pin. So right now in the down position, it would be like this. It'd be controlling this. And then in the up, now it'd be controlling up. So with this whole setup, when the switch is up, say it looks just like this. This is up and up. The red and the blue light will be on. And then when I put it down, if we have it set up as this shows, then it would be going down into the green and down into the yellow. So at any time I can have the red and the blue light on, or flip switch and the green and the yellow light will be on. Hopefully that made sense. That's a quick overview of switches and what we're going to be doing with going forward. Next video, we are going to be completing some circuitry with our switches and testing them out with our power, and we'll be doing some simulation in multisim as well. All right, thanks for tuning in.